In this video, I will be talking about electrolytes. So obviously, the first thing we have to do is define what electrolytes are. So, electrolytes. So, essentially what an electrolyte is it's a compound that is soluble in water and can generate electrically conductive solutions. So let's write that down. So it's a compound that can generate electrical. So first, let's say that it's soluble in water. Soluble in water, and well, it can generate current. It can generate electricity. So it generates electricity. So well, we have two basic types of electrolytes and something that we call a non-electrolyte. Let's talk about each of them. So strong electrolytes. A strong electrolyte is able to ionize 100% in solution. So it ionizes 100% in solution. And well, what does this mean? When something ionizes, it will result in charged particles which can move. So you will form, as the name says, ions. There will be positive ions and negative ions, also called cations or anions. So if we're saying that something will ionize 100%, it means that everything will become an ion. That compound you had will be able to separate into a cation and an anion completely. Like, there will be no molecular compounds left. So your strong electrolytes will usually be strong acids and bases and most of the ionic compounds. Let's give an example of a strong electrolyte. Well, it's the same example we always use. So NaCl is an ionic compound, and when you put NaCl in water, so it'll go into water, it is able to ionize 100%, which means the Na plus will separate, and the chlorine ion will separate too. So you see no molecular compound in there. Everything is an ion. We have the cation here and the anion here. So you should be able to identify strong electrolytes pretty easily when you see ionic compounds or the strong bases and strong acids. Now let's talk about the weak electrolyte. Oh, weak. So a weak electrolyte partially ionizes in solution. So partially. So instead of that 100% in a strong electrolyte, it will be like a 30% or 40% depending on how weak the electrolyte is. And this is what usually happens in molecular compounds, like let's say acetic acid. So acetic acid, its formula is CH3COOH. I missed this part. And it reacts with water to produce CH3COO minus and H3O. And this is a cation. Well, as you can see, not everything ionized, not everything was able to separate into parts. This section here is still kind of together, so it doesn't have 100% ionization, but there's a still ion formation there. There's still some ionization. It can be 0%, but if it is 0%, then we have something we call a non-electrolyte. Electrolyte. So, well, they don't ionize at all. A molecular compound will say as a molecular compound. Like, let's go with this. It's 1205. And you put water here, and it will still be the same. Nothing happened to it. So, this is what we call a non-electrolyte. There was no ion formation. Nothing was able to separate into parts. Well, as the definition of an electrolyte says, it will not be able to carry any charge. So it doesn't produce any charge. So let's give you a way for you to remember this better. So this picture has three light bulbs, and well, an electrolyte is able to carry charge, right? So if you think about it, a strong electrolyte will have a very bright light bulb, so very bright. However, a weak electrolyte cannot carry as much charge as a strong electrolyte will, because it doesn't ionize 100%. So the light will be dim. It won't be complete. It won't be as bright as it could be. But there will be still current there. So it will light up a little bit. So this still has current. Still has current or electricity. But when we get to the non-electrolyte case, there's no light at all, because if something is not an electrolyte, it cannot have any charge. It doesn't ionize, and there's not going to be a cation and an anion to produce a charge there. So the light bulb will just remain as it is, no light at all. So this is a very good way to be able to remember them and separate them from each other.